So the continuation of the previous lesson, if we remember the previous lesson, we adjourned our discussion in locating elements according to their electron configuration. So we have seen the S block, locating elements in S block and P block. So let's see how these elements are assigned. Without looking at the periodic table, identify the period, block, and group of element that has electron configuration, this one. Once electron configuration is given, and this is given in the form of noble gas notation, because we do have a series of configuration here, but it is all compiled and given as in terms of argon. The atomic number for argon is 18. So we do have 18 electrons here inside, 18 electrons. So 18 plus 7 is 25. 25 plus 2 is 27. So we do have 27 electrons, or the atomic number 27. So without looking the periodic table, identify the period block. So the first one is locating period. As we have seen, if an element is in S block or P block, you just locate, just see the outermost shell. In any configuration, the outermost shell principal quantum number tells you the period. So since the outermost principal number 4, this indicates period. It is period 4. And the block, here we must take care in deciding the block. If the block is in D block, it is a combination of one pattern block. If it is in D block, the pattern must be, if it is in D block, the pattern must be in N, S something, N S1 or 2, and N minus 1 D. It should be with this pattern. The S. No problem if we are arranging according to the energy, the shell, according to shell, not energy. Actually, the electron here has more energy, less energy than this one. But according to shell, the third shell is inside and the fourth shell out. So we can put this one here, no problem. So can this satisfy this arrangement? The last two, if they are obeyed by this one, we can say it is D. Look, N, the last shell 4. Here is 4, S2. 4 minus 1 is 3. Here it is, 3. D7. So it's obeyed by this rule. So it is D block. The block is D block. So the period, block, and group. In order to decide the group, just add the electrons from both this one and this one. So we have 2 plus 7, which is 9. So the group, it is found in group 9. Group 9. So the period is answered, the group of the element is answered, the block is answered. So the element argon with this configuration, an element having 27, which is cobalt. So cobalt is 27, is located in period 4, block D, and group 9. Now you can open up your periodic table and see period 4, go to D block, and starting from the first age, group 1, group 2, group 3, group 4, when you reach at group 9, you can easily locate cobalt. So you can find cobalt. So the next question will be, so the next question also simply locating elements according to its electron configuration. So without looking at the periodic table, identify the period, block, and group in which the elements with the following electron configurations are located. So we have neon, it's written in the form of noble gas notation. So now what we are interested is on this, the remaining stuff. We are interested here. We're interested here, and also the same shells we are interested here, and at the same time we are interested here. So this will give us some information about the block, period, and group. So in order to answer A, B, and C, let's write first period of the element, then block, and then group. Let's see. As you can see, the last electron enters in the principal quantum number n is equal to 3, and the last electron, even though it is in the main shell 3, 3, the distribution is in some part in S and in P also. So there are 4 electrons, the remaining 4 electrons enters in the P. So the block is P block. The period is simply see the outermost shell. It is the third shell. So period 3. Group, to find the group, just add the total number of electrons found in the same shell. This is one of the electron and this is the other electron. 2 plus 4, which is 6. So group 6. Again, when we come to B, since 5s and 5b, had it been 5p is absent from here, it would have been transition metal, because it obeys ns2 and n-1, which means n-1 is 4, so it would have been d block, but still it is p block. If you see, the maximum, the outermost shell is 5, so it is period 5, block P, and group, just add the electrons found in the same principal quantum number, or the same n, which is n means this is n, so that add the total electron you have in order to know the group number. So it's group 4. And when you come to the last one, you end up with here 6x and 6p. So the outermost shell is 6, so it directly indicates period. The block is still the last electron enters in P, the last electron, the last 5 electrons are in the P, so it's still in P block. And the group number is, as we said, simply add the total number of electrons that exist in the outermost shell, which is, we have 5 here, we have 2 here, together 2 plus 5 is 7. So these are some of the typical examples to illustrate the configuration of